Good evening, ladies and gentlemen. I apologize for not streaming in the past week. I've had a very busy week, and I didn't think, um, but I have had a little bit of time to figure out what was going on with all the quaternion rotations and stuff. Unreal is still loading here. Um, it is just taking its sweet time, so we'll let it think. Um, and in the meantime, I'll just kind of walk through what I figured out with the rotations with you, and then after that, we will work on setting up an importer for Unreal Engine. We're not going to get an importer done today. I doubt we're even going to load a mesh today, but we're going to get started, get all the engine components set up, all the plugins set up, and that'll work nicely. Okay, do you remember our apply input to rotation function? The first thing that I would like to remind everybody is don't follow the Unreal's method of setting up functions and stuff, because Unreal is incredibly optimized, and optimization reduces readability. It makes it very hard to tell what's going on. It makes it very hard to figure out what's going wrong. So, for example, this line here. Why would we compare size squared and then get size or 0? Like, what's the point of this? If size is already 0, wouldn't we just assign to size? But no, the reason that we do this is because it is faster to look at size squared than it is to look at size. So this is merely a optimization. Now I'm a little confused as to if this is truly an optimization, because a comparison is usually slower, but maybe the branch predictor on a CPU doesn't mind this one at all. Can just skip right over it. And then there's a whole bunch of stuff they do here that makes it harder to read. For example, they don't handle actually setting the velocity in this function. They handle that elsewhere, and that makes it harder to read because you can't, see where the velocity is set in one place. You have to go to two places to kind of figure out what they're doing with the velocity. And so I've gone ahead and done away with basically all of that. I've done a little bit of error handling here, but that's about it. Or I should rather say error avoidance rather than error handling. But I'm setting the rotation in this I'm setting the rotation in this function. I think I accidentally uncommented something. Let me check real quick. This looks weird. I should not have both functions active here, I don't think. Anyway, so I've got it all in one function, and I've got, and I'm not doing any optimization. I'm just doing it as straight as possible. So, taking a look at this function, the first thing we do is just get things in radians. It's usually easier in the interface to put numbers in degrees, but sometimes it's easier. But for all of the rotations and stuff, you want it in radians. Yeah, you just want it in radians. Now, something to remember is that a quaternion times a float. This is not the same as a vector. A vector, we get double the magnitude just like that. But this is not how a quaternion works. If you multiply it by a float, it doesn't do what you think it does. Notably, it actually messes up the quaternion. This is now a quaternion of 0002, which is an invalid quaternion. Quaternions must add to 1, or the size of a quaternion must be 1. They're not 2. The size of a quaternion can't be 2, right? So multiplying by a float is actually incorrect when you want to set the um, uh, magnitude of quaternion. But something Unreal lets us do is split the quaternion up into a axis angle system. And you can actually think of quaternions as axis angle rotations that have a little bit of math done to them so that the axis and the angle are in the same coordinates. That just makes things much easier to do math on because you don't have to think of the axis and angles separately. But sometimes it's really useful to think of the axis and angles separately. So when we want to go ahead and change the angle of rotation, we want to make a new quad with the rotation axis of our old quad and a new angle. All right, this is just going to change how far the rotation was. And then if we're going to be going against the old rotation for velocity here, we want to, of course, get an updated component. And then I'm creating a new angular velocity that's going to be different when we're accelerating or decelerating, only because of this acceleration-deceleration factor. Basically, what we're looking to do is have that be different based off of user input on the blueprint. So this angular deceleration factor is incredibly important that it is between 0 and max angular speed, because it's actually incredibly important that the angular deceleration factor be between 0 and 1. We'll get into that in a second. And because I don't want the angular acceleration and deceleration to be a percentage, because that's confusing, I am locking it to be between the 0 and max angular speed, right? And then dividing it by max angular speed to turn it into a percentage of max angular speed. Now, the reason it would be confusing if it is a percentage is if you change max angular speed, you're going to change your acceleration if it's a percentage. So by making them both in radians per second, or actually I think this is technically in yeah, I think this is in radians per second and this is in degrees per second, but we can ignore that for now. No, they're both in degrees per second because this is the same units as that because I'm doing division. Anyway, so by making both in degrees per second, it's much easier to make adjustments without having one adjustment affect all of the other adjustments. And then we are ensuring we are going on the shortest possible path by using a slurp. So we are, when we're deaccelerating, we're taking our current velocity. By the way, this is a local coordinates, and we're going to slurp, which is a spherical linear interpretation. Lazy? Let me look up the acronym. Yeah, it is. It's spherical linear interpretation. Ain't that gonna drive you batty? If it's spherical, it's not linear. But no, what they're meaning is it's a linear percentage. So we have a spherical linear interpolation between angular velocity and identity, and how much. Basically, this is going to decide how many, more or less, how many frames it takes for us to get from 0 to the max deceleration or from our current velocity to 0, right? And that's somewhere between 0 and 1. And then if we are accelerating, what we want to do is slurp between our current angular velocity and the max angular velocity we can possibly have, which we determine by multiplying angular velocity by acceleration full. Acceleration full being our vector that we've created here that is the axis of rotation at the max angular speed. So by doing that, we are targeting our max angular velocity, and we will get there. And so this max angular speed actually matters. Right, it's a real number. It's not just some arbitrary number that's affected by other things. Then we want to make sure that that we're not going to accelerate ad infinitum. So we're going to clamp our max angular speed we're going to clamp our angle of our new velocity to max angular speed. Then we're going to rotate our new angular velocity from a local vector into a world vector and ensure that we have the shortest arc with our current vector, right? If we don't ensure that we have the shortest arc, then when we get to 360, we can go the wrong way around. And it's very jerky because of that. So basically, instead of going from 0 to 360, we could go from directly. We go from 0 and then we go 1, 2, 3, 4, 5 and get to 360 that way, the wrong way around. And then we're going to set our world rotation to target rotation, and we're going to go ahead and rotate our new rotation that we're shooting. Yeah, we're going to rotate our new rotation that we just set our rotation to by the inverse of our old rotation, which is going to give us the difference between, it's going to give the difference between this, and the difference between these two is our velocity in local space. And then of course we want to reset rotation input back to 0 so when we let go of a key, we don't rotate forever. Okay, so I'm going to pull this over here and show you what that looks like. All right, we go, give me a click. We can go up, we can go down, we can go left, we can go right, we can rotate, right? And this works no matter what we're doing. Now I'm used to flying with the joystick, so this is flying with a keyboard is really bad. And I'm probably making you all sick here, sorry. Anyway, but it works perfectly. Now, something I found interesting is that it doesn't seem to work quite correctly if I do this. This is why this was in here, is I was experimenting with this. Basically, if we use the built-in add local rotation, and comment this out, yeah, right, we have to do some reconfiguring here, but if we use the built-in add local rotation instead of calculating the world rotation ourselves, like if we let let me correct that. If we let Unreal calculate the world rotation by using add local rotation, instead of calculating the world rotation ourselves, it doesn't work. It messes up horribly, and I don't know why. Now, I do know that add local rotation does a number of stuff that I'm not actually comfortable with. Right? If we actually go to what this does, you can see that it starts out by getting a current rotator and converting that to a quad, which is a little bit weird. Um, and then it looks like it sets it to world rotation here and in here. I think this one? Yes, this one. Right? Conditional update component to world, or sorry, calculate new component to world desired relative transform. It looks like we just did that twice because we just turned our um, our transform into, or we just turned our rotation into a local rotation. Um, Here, this is turning our this is turning our delta rotation into a rolled vector, and then we just do it again. That's not correct, right? We're taking our relative transform and converting it to world again. We're already in world. So I'm not certain what's going on here. But I think that add local rotation might not be exactly what you're looking for when you're wanting to add local rotation. I recommend doing it yourself. Like so. Now, obviously, that means that you're going to have to handle collisions yourself. And I haven't figured out how to do that yet. But looking through it, it doesn't actually look like it's too hard. It looks like the physics system does a lot of work for you to make sure you're doing the right thing. So I'm just going to go ahead and add a couple more comments here so that these logs don't get in our way, and build this out. Oh, shoot, what just happened? Oh, okay. Just taking a second. All right. So now let's talk about importing. I think I need to go to logo for just a moment here. Make sure you guys don't see something inappropriate. Inappropriate meaning for work. You can't see my work stuff. Nope. Oh, all right. Yeah, OBS crashed on me. My bad. We are back. Okay, so this is the source code for Descent 1. All the Descent source code is open source online under a use for nonprofit license. Yeah. So, what I am looking at right here is the load mine data function in the original Descent. And basically, what we want to do is load up this, is create an importer in Unreal to load the, basically run this function and get a mine loaded up to start with. We're also going to need to make importers for textures and polygonal objects, mainly the bots, but it's all the data format is in here. We can find everything we need. Okay, so let me pull this out of the way here. Now, this is the kind of thing that AIs are really, really good at. So I've put this code into an AI, and I will be kind of basing my system off of that and checking it against the Unreal documentation. Um, so to start with, we need to create a new C++ class. So grab Unreal over here. We go to Tools. Thought it was Tools. There it is, right in front of me. New C++ class. We're going to go to All Classes. Although most of the time you're going to be deriving from actor, pawn, or character. Generally, you want to be deriving from, or there are plenty of times when you want to be deriving from something else. In fact, I'm not even sure most of the time you're going to be deriving from these. Actor, maybe, but there is a whole bunch of stuff in Unreal that you might want to derive from. Actor components are a big one that you want to derive, that might be useful to derive from. Now, um, the AI recommends that I make this a derivative of object for my importer, which makes sense, right? This isn't really something that gets placed in the world per se. Yeah, it's not really something that gets placed in the world per se. It's something that kind of gets called as we either click on a button inside the editor or as we load a level. So let's go ahead and just make it from object to start with. And we're going to call this, make this a public class, and we're going to call this, what do we want to call this? Yeah, we'll call this view mine importer 01, because I'm quite certain I'm going to mess this up at least once. All right, click create class. It's going to recompile. I think we're going to need a second class or second C++ class to be created. We'll look at that in a second. Basically, we want a class that defines the structure of a mine and a separate class that does the importing. That's basically going to run through that structure and put things in it. So the reason that I'm, whoops, the reason that I am Unreal insisting on being on top as usual. Okay. All right, Unreal. You completed your compiling. Fine. We can do some more work with you. Ah. Okay. So we've got our UObject UMine importer, UMine importer. Whoops. Told you I'd mess up. That's fine. So let's create another C++ class. And we want to go to all classes again. And what we want to do is search for struct. So we're looking to create a ustruct. And I don't know where I'd find it here. Okay. We have field structure. We have factory structure. That might be it. And we have simple nope, that's not it. Okay. According to our API reference, ustruct is a field. So we want the field struct. So we're just going to call this mine, I think. Yeah, just mine. Maybe we call it D1 mine, right? Because we're going to make a structure for every single descent, I think. So let's call this D1 mine. It doesn't like that. What doesn't like about that? I don't know what it doesn't like about that. Okay, let's cancel that. Maybe we need to reload. Okay, so we're just going to rebuild from editor. See if we can minimize Unreal. Oh, that was fast. So tools, new C++ class, all classes, struct. Next. It does not want to make us a struct, does it? Is that because it's a struct or because it's not happy making classes right now? That's because it's a struct. I'm not seeing any not seeing anything interesting on what I'm researching here. All I'm seeing is just kind of this is what a struct is stuff. It's like, yeah, that I know what a struct is, but how do I make one with Unreal's convoluted build system? That's the important part. Unfortunately, this link is old enough that it doesn't work. Sure. Right, so we've got this using structs. Structs are use structs, implementing structs. Open the header of H. It looks like I just make a new header.h manually, which is very odd. It's very not Unreal. So we'll go ahead and cancel this. And head over to our system and that's weird. There's going to be a struct, and the name is going to be mine. What is the name going to be? Mine something. Probably. Nope, they don't usually include that in the. Okay, so mine.h. All right. So we want to go ahead and only copy some of that text. Let's see here. Doesn't exist yet. And of course, it needs to be in fmine. Whoops. Okay, we're good. Fmine. And then we need generated body. And we are going to save that and include it here. String, of course. And let's go ahead and hit build and see what we come up with. If we come up with something good, then we're off to the races. So we're going to start by getting this importer working in the editor, and then we'll add it to a level loader. Did not know that. Easy to fix. Okay. So, while that's recompiling, the original Descent and Descent 2 code held, didn't really do polygons, they did cubes, distorted cubes. And so that they called segments. So you've got a segment, which is a six-sided cube that's distorted, and then each of the sides of the segment can have a texture, a light, a door. It can be gone, right? It can be invisible. There's a whole bunch of types of segment, of types of faces that each segment can have. And so that's going to be a little bit tricky for us to load into Unreal, right? Not because that's turning all that into a mesh is tricky, but because that some of those individual faces are really separate objects, right? So if I want a door in Unreal, I really want that to be kind of a separate object, not part of the mine the mine mesh, right? I want a mine mesh that doesn't include the doors, that doesn't include any removable walls. Basically, nothing that can change should be in the mine mesh. It should be just a static mesh. And then we can add in the doors and the walls and the switches and all of that as secondary meshes, as decals, maybe, for some of them. Mesh. Anyway, the point being is that loading up each of these segments is going to be a little bit complicated. Initially, we'll probably just load up everything without doors, with all the secrets exposed, everything just the just the normal walls, just the walls of the mesh. No doors, no special areas, no triggers, nothing, none of that. Just the walls of the mesh. But he doesn't like that. Maybe if we regenerate the project files, it'll be happy with us. Let's kind of look at let's see if we can find that. Don't know. Writer's still not happy. Still not found. And that's not what I wanted. Minimize. That's what I wanted. So what happens when I delete this and compile? It's probably going to yell at me that it doesn't know what all the Unreal functions are. All the Unreal tags. Bingo. Not sure what's going on here. Okay. pull this over so you guys can see. Generated.h, not file not found. File not found. Wait. No, that's right. We've got a class, we've got a generated body. Struct def mine. But it's not generating the .h file. Huh? Okay, this guy's not having the same issue as me. Third-party plugin, this is not... Makes sense, no. Well, I haven't gotten as far as you. We can try that. Now, I thought this was kind of an older UE4 thing, the specifying what type of body, but I could be wrong. Same idea. Mine header generated.h. Stupid copy paste ridiculous derp. Always pay attention to what you're copy pasting. We didn't call it mine header because we aren't implementing the header, we're implementing the whole thing. Ta-da! Much better. Okay, apparently that's how you do it. All right. So now we want to go ahead and pull in some properties here. Okay, sure. Blueprint read only, that makes sense. Category mine header, that also makes sense. So, Descent is one of the very weird games that stores multiple levels per file. It stores up to, I believe, 18 levels per file, including secret levels. And so mine data offset is which level are you on, right? So um, you've got your signature, your version, your mine data offset, game data offset, and hostage text offset. The important things is going to be the mine data offset and the version, right? Because we're going to be loading multiple versions, so we need to when we import a mine, we need to make sure we imported the right version. Right, we're going to be doing at least descent 1 latest patch and descent 2 latest patch. Okay, so mine importer.h. We're just going to have one function for now. And, whoops, that is not, there it is. We're going to implement that function here. And we are making a mine, not a mine header. And of course I named it wrong. Oh, EU mine importer 01. There we go. It doesn't? Oh, we just called it import. Import. Okay. This is fine for now. All right. So for importing to Unreal, Unreal has a class called a file reader, or rather an farchive. And this this class can read things byte by byte utilizing the serialize command. And so we can say we want the signature, and it's an int32, meaning a 32-bit integer. We can specify the type of thing it is and the number of bits going on here. Incidentally, almost most modern languages use these int32, int16, int64s as their types instead of long double shorts. Sorry, int long short, doubles float type. And that makes so much more sense. You actually know what you're getting. That said, it can be a little tricky if you try and compile something that has an int64 in it to a 32-bit system. Which is why C has the weird naming in the first place, honestly. Because an int wasn't always going to be an int32, or rather an int16 rather. When C was first invented, int was int16. And then it changed to int32 on 32-bit systems. So there is some merit to doing it C's way. It just is really confusing to read. Okay. So we want to get, we want to open a file at the appropriate file path. We want to read the header. We want to check that the mine signature is PLVL, and this is according to the descent source code. We want to close the reader, delete the reader, and return the header. Fair enough. All right, now we need to create a new editor utility widget. Whoop. So we're looking to create the button to let us click on it to test if we can import this thing. So right click, editor utility widget. We might rename this later. This might just be a general importer. So we need to add a button. Leave editor utility button. Wait. Okay. Why am I not seeing it? Okay, we got our stack box. Oh, orientation needs to be vertical. Okay. 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 Yeah. Gotcha. Style. Sure. Defaults are fine. Blah blah blah. Where? To import D1 level. Now we're going to need to add things to this button, like a text field to do stuff with. Let's go ahead and call this import button. And where do I say like the default text? No idea. On. Okay. I am a little confused. Probably need to open up the documentation on this instead of just randomly guessing stuff. Let's go ahead and add. So I also think I need to add some text. Oh. Here, and call this output. All right, so basically what we're going to do is import the, actually we'll just call it header. Yeah. So when we import the header text, we're going to display it here. Okay, so if I'm reading this right, I need to figure out how to bind the click event. Right, it's a button, right? Did you have a click event somewhere? util button. There we go. Okay, we create a utility widget. Wait. I'm confused. I don't recall seeing a button class. I didn't have a button class. Okay, so it must be an earlier screenshot. Edit as needed. Thank you. That is super helpful documentation. I don't know how to bind on click. Right, I can bind, create binding. Well, I didn't want to do that. Back to designer. How do I remove a binding now? Oh, great. Remove binding. There we go. So I can bind to tooltip text. Huh, it has to be is variable for on-clicked? I'm confused. What does it have to do with the clicked event? Okay, so we've created an on-click class. Now, interestingly enough, my the AI here thinks that this is should be a C++ thing. I've got no clue where or how it's expecting me to do that. I might be able to do it here. Suppose what I want to do is come on. What's wrong with my keyboard? Nothing. Let's not be scrolling through those blindly. What does mine importer? Mine imp. Okay. Oh boy, now I'm confused. So I don't know how to create the C++ for this. Compile, save. Do I just right click convert to C++? It's not there. Okay. There's no text on the button. Okay. Oh, I did not want to do that. Not understanding this at all. Documentation on editor utility widgets appears to be very sparse. What? My bad. What? None of this makes any sense. Yuck. Okay, so what my AI is telling me now that I asked it, how do I get this into C++, is it can't be both in the editor and in C++. If I want it to use in C++, I have to fully create it in C++. Creating UIs in code is, I hate doing that so much. But I'm not, my function doesn't appear to be exposed here. Right, we've got the mine struct, but I'm not seeing the mine importer. So mine importer doesn't appear to show up here. And I do think I want to change the name of the import function because I cannot. There's a lot of things named import. So I'm going to change this to import mine. Import mine. Sure, I'm reading this right. This is a blueprint callable. Blueprint callable. It is public. Oop, need to recompile. Compile complete, and I think that sounded successful. Yep, successful. Okay. There it is. Much better. So we got file path. Yeah, okay, this is great. This is great, actually. So I assume we need to head back here and say that this is variable. So we can get it here. Wait. Why can't I set header text? Okay, I'll have to figure that one out. File path is going to be that doesn't seem right. We're looking to do project directory. There it is. Project directory, and then we want to know so then we want to append project directory isn't right. For now, I'm just going to type it in myself. All right, we'll just do the absolute path, and Where is it? All right, we are putting this in documents, code, descent. Oh, no. This is just the source code. None of the levels are here. I don't think. So I need to find it where it is on my Steam directory. Ah, updating. What's going on? Doesn't explain why I can't do anything on Unreal right now, but that's what's going on. Okay, and basically what we want to do is we want to import the mine from the return value. We want to set some text. I'm not sure why we can't set this. So let's go and go figure that out. Steam thinks about what it's doing. Hopefully. Okay, so text block. How do I... I have no clue what my computer's doing right now. It's really annoying. Maybe... Oh, this is working just fine. Sounds exactly like what we're looking for, maybe. We can create a string variable in your widget. Click the text widget. Click the bind button next to the text. Pick the string variable. Okay. Great. Right, I set it as variable, but it wouldn't let me... Do I need to save and compile this? Once again, Unreal locks up for just random reasons sometimes. Oh, nope. Let's pull you over here. What is going on? Like, now I'm starting to get worried. This is bad. Let's check on descent. Let's go ahead and pause all updating of games because poor hard drive is not happy. Alrighty then. So our official target is going to be no idea. Also, look at how simple this file structure is. This is the entire game of Descent. We have a config file, a fact file, a couple of hog files, which I think might be what we're going for. Why don't we actually Google this? So descent. Unreal's still fighting me. Big time. Okay, we're going to close Unreal and get it restarted here. Because it's... I don't know what's going on. But something's not happy. Okay. So in the meantime... level file. Alright, this is what the MSN file looks like. I'm a little confused because there's no .rdl files in here. Let's see here. Is there nope. Still nope. There doesn't appear to be a descent.mission file, but it seems that .hog files are going to be our levels. Um, descent.hog or descent.pig. I'm not sure which it is. I do think that there's a limit to the number of levels that can go in one file, so maybe this is files 1 through, or levels 1 through 20, and this is 20 through 30 or something like that. That would be interesting. Okay. So let's go ahead and get this thing. Well, we need to fix the loader here. That one. Save and run. Okay. So while it's loading, let's see if we can figure out where the textures are. Because I know where the vertices are. I know where the faces are. But I don't know where the textures are. We got UVs, texture map number. Texture map number. I hate how slow VS Code is on large code bases. Should open this in NetBeans too. Texture map number 2. Okay. So a side has a texture map number. Can we go to... I am not seeing side defined here. Is it defined here? Nope. Okay. Going. Texture offset. This is confusing. Game load mine data compiled. Underscore mine. No results. What? I didn't know you were allowed to do that in C. Load mine data compiled new. VS Code is just refusing to search this correctly. Okay, we got it in mine.h. We have it in gm.c. Load mine data. Okay. Load file, open. If we opened. If we didn't open, return. If we opened, load mine data. cftell. Not sure what that is. Fuel send reset. Oh, fuel center. We don't do anything with reading here. We can skip past that for now. We are saving fuel centers for a later date. Interesting. We store how many times we've used a texture map. I'm thinking that I'm told it to load the wrong things, and we're too deep in. Because I'm assuming we. Oh, there's Unreal again. Maybe sometime this century. Okay, let's continue looking at this. We go ahead and initialize all of the variables. We still haven't done any reads. So don't understand what this got it. Okay, so we go to the top of the file, and then mine top file info. Okay, we had that somewhere. Okay, so we read this to start with. Okay. Okay. um, we read this to start with. We check the version. And then we go back to the top. Back on top of file. Load till size of. Right? Yeah, this is a read. Okay. Number of vertices equals 0. Number of segments equals 0. If header offset is greater than -1, we load the header. Right, because we just loaded all of this. Okay, we just loaded all of this. Just that? This. You can tell somebody's written the data structure before. Okay, so we load all of this. So we don't load the whole file, we load this, correct? Yes. I'm confused as to why we're using the size of the file info size of here instead of the size of mine file info. Anyway, so then we load the header, why this is not wrapped in an editor? We load the editor stuff. We load the texture stuff. Yep. We do some stuff to make a table of our textures. We don't do any reads in there, right? Yeah. We're going to make sure we don't have too many vertices. I don't think we have to worry about that in Unreal Engine. Just a thought. We can probably skip this one. If we have some vertices, then we seek to here and we iterate through each one and we load the vertices into vertices. We do the same thing for segments. Interesting. So if we're loading older segments, we go through a lot of work to make sure that we load them correctly. That's very interesting. I don't know if we want to be able to load older segments or not. I think we'll start with the V16 segments and go from there. We'll just throw an error if file info version is less than 16. We don't do anything with the editor. Where'd our for loop end? That for loop. All the way down here. Okay. Still don't do anything with the editor. Still don't do anything with the editor. Create local segment data. We find our textures. Okay. I must have been looking at an old loader. Wait, but how do we load in the objects? We didn't load in the objects, did we? Nope. Not here anyway. Okay, notably, mine file info is declared globally. Oh, that's annoying. That is incredibly annoying. I don't know where we're loading in our objects. Or our walls or our triggers. Actually, I think I know where we're loading in our walls. Probably our triggers too. I don't know about the groups. Or even what new segment vertices are. I don't know about the objects. That's interesting. Okay. All right. Okay, it's not letting me set that, so instead we can go ahead and create a header string, like so. I don't think this is going to quite work how I think it should, but let's hear. Where we go ahead and we'll set this. Set header string. And then we're going to have to construct the string manually. We're just going to do signature inversion. To string. Suppose it's not quite how I want to do this. That's fine for now. Voila, voila, voila. And we of course want to do descent.hog, like so. Save and compile. Now, what I'm trying to do right now is just get a button set up, even though we know we're basically certain it's not going to work because mine is in the wrong format and all sorts of stuff. But If we can get this compiled and failing, then we can test it next time. This out of my way. What do we do next? Uh-oh. Clearly, I need to take a closer look at one of my functions here. Assertion failed. Oh. Okay, I didn't want it to crash on assertion failed. Ouch. Like, I think this crashed the whole thing. Okay, good to know that assert causes some sort of crash. Like it's intentional. It's trying to cause a crash. So we don't want to do that. Let's go ahead and head over to our JetBrains. Oh, there it goes. It took a while. No hot reload, so it didn't change that. Okay. Yeah, we don't want to air out. Let's go ahead and kill that one. We'll have to, because we don't want to drop all the way out of Unreal. We want to drop out of the importer and display an error. Maybe return an error. We'll have to figure that out. Yeah, here we go. So I'm trying to figure out if I want like, can I have multiple structs in here? Does this work? If this works, this is great. Also, that means mine.h is incorrectly named. We'll have to figure all that out. All right, ladies and gentlemen, I think we've made it far enough today. Tomorrow we will be focusing on getting the initial load of a file based off of the code we have found here. Let's roll to the top here. Yeah, this code, game load mine, and load mine data. Yeah, basically we were just looking to load everything into the appropriate data struct, and then what we're going to do after that is we're just going to try and get everything loaded into a proper data struct tomorrow, and so that in the day after tomorrow and in the coming weeks we can go ahead and build up all the functions to convert that data struct into an Unreal object, or Unreal objects plural. There's all sorts of weirdness in here. What's this? Good to know. Why is it declared here? Okay. Well, with that, I will bid you all adieu. Farewell.